Welcome to today's lesson. We've been handling or tackling some questions dealing with probability in various ways. Previously, the last lesson, we were looking at the Venn diagrams and the two-way table, but I just want us to continue with the Venn diagrams so that we get to understand exactly how do we represent data or the collected information on a Venn diagram. So we will look at it basing on questions. So the first question that we have is, so we are having the Venn diagram that is showing people who have a university degree and those who are employed. So I have university, then the other circle is for the employed. So we find that 3 have a university degree, 5 are employed, and among those who have a university degree and those who are employed, those who have both a university degree and employed, we have 10. Then we have those who do not belong to any of those categories. They do not have a university degree, they are not employed. We have 2. So the question is, so how many people are in the survey? So we find that out of this survey, 3 have a university degree, 5 are employed, then 10 have both a university degree and are also employed. Then we have 2 who do not have a university degree and at the same time are not employed. So the total number of people who are surveyed in this survey, we simply take the numbers we have and get the sum. So we have 3 plus 10 plus 5 plus 2. 3 plus 10, that is 13. 13 plus 5, 18. 18 plus 2, we get 20. So this survey was conducted on 20 people. Then the question is, the second question, so we find the probability that a person selected randomly has no university degree but is employed. So this person does not have a university degree, but the person is employed. So what do? We find out the number of employed people. Then this person has no university degree. So it means the 10 who are employed but have a university degree do not fall in this category of the question that you want. We only need those who are employed but they do not have the university degree. So it means I have a total of 5 people who are employed but do not have university degree divided by 20. So it means the probability of getting a job even without a university degree is 1/4. So that is the first question that we are using a Venn diagram. Another question to consider as we look at the Venn diagram So the second question we have, in a group of 30 students, it is found that 10 play both cricket and soccer, 5 play only cricket, and 7 play only soccer. So the first question is, how many students do not play cricket or soccer? So we are having a group of 30 students. Out of these 30 students, we find that we are having 10 who are playing both cricket and soccer. Then we have 5 who are playing cricket and 7 who are playing soccer only. So we have those group of students who do not participate in either cricket or soccer. That is what we need to find in this question. So if there are 30 students, out of these 30 students, we already have those who are playing cricket and soccer are 10, those who are playing cricket only are 5, those who are playing only soccer are 7. So for us to get those who do not participate in any of the events, then we will take 30 minus the sum of the details we have, that is 10 plus 5 plus 7. 10 plus 5 is 12. 10 plus 5, 15. 15 plus 7 is 22. So we have 30 minus 22, which gives us 8 students. So we are having 8 students do not participate in either cricket or soccer. The second question we are asked to represent the survey findings in a Venn diagram. So we are representing whatever we have on this survey on a Venn diagram. So we are having 2 types of games in this case. We have cricket and we have soccer. So we draw the 2 circles representing cricket and soccer. So after drawing the 2 circles, we find out the details we have in the question. Keeping in mind, the students who are participating in the 2 events will be written at the point where the circles intersect. So we are having 10 students who play both cricket and soccer. So they play the 2 games, meaning they are at the point where the 2 circles intersect. So we have 10 participating in both cricket and soccer, then 5 playing cricket only. So we have 5 playing cricket. Then on the other side, 7 playing soccer only. Then from our first calculation, we noticed that we have those ones who do not participate in cricket or soccer. So those who do not participate in any of the games are 8. So we indicate our 8 at that point. So we've represented the data that we've been given on a Venn diagram. 5 students play cricket only, 7 students play soccer only, 10 play both cricket and soccer, then we have 8 who do not play either cricket or soccer. So this is the representation of the detail we have in the question. Part C of the question, we are asked how many students surveyed play cricket. So we have how many students play cricket. So we find the students who play cricket. How do we get these students who play cricket? We have students who play cricket only. At the same time, we have students who play cricket and play soccer. So that means to get the total number of students who play cricket, we will obtain it by those students who play cricket only, that is 5, plus the students who participate in both cricket and soccer, which is 10. So we get that the students who play cricket from this diagram are 15 in total. So the question is, how many students surveyed play cricket or soccer or both of them? So the question is asking us. This is whereby our or is inclusive, meaning that it is either the question is requiring us to find those students who are playing cricket, we find the students who are playing soccer, and at the same time get the students who are playing both soccer and cricket. So that means that we will be having 5 for those students who play cricket, then we have 7 for those students who play soccer, then plus those who play both soccer and cricket. So we get that we have 5 plus 7, that is 12. 12 plus 10, we get 22. So the students who play either cricket or soccer or both in total are 22. So we are being asked to find how many students surveyed play either cricket or soccer, but not both. You discover that this question is different from the previous question that we've worked out. The previous question was asking us to get the students who play cricket or soccer or both of them. But in this question, we are being asked to just get those students who are either playing cricket or soccer, but not that they are playing but not those who are playing both cricket and soccer. So we find that our or is exclusive. So it is excluding those who are not playing, those who are playing both of the games. We only need the two who are either playing cricket or soccer. So for those who are playing either cricket or soccer, we get that those who are playing only cricket, we have 5. Those who are playing only soccer, we have 7. So in total, we have 12 students. So we have another question, that is question 3. The Venn diagram shows the number of people surveyed who like juice and or soft drinks. So we are having those who like juice are 10. Those who like soft drinks, we have 14. Those who like both juice and soft drinks, we have 2. Then those who dislike either of them are 4. So the first question is, what is the total number of people surveyed who like juice? We need to get the number of people who like juice. So juice is in this circle. So we are having juice at this point. So we have 10 people who like juice only. We have 2 who like both soft drinks and juice. So the total number of people who like juice only will be obtained by 10 plus 2, which gives us 12. So we have 12 people who like juice only. Who like juice in that case. Either they like juice only or they like both juice and soft drinks. So the total number of people who like juice from this survey will be 10 plus 2, which gives us 12. So part B of the question is requiring us to find the probability that a randomly selected person likes neither juice nor soft drinks. So this is whereby this person does not like juice and at the same time the person does not like soft drinks. So we had a category of people here who do not fall in juice, who do not fall under the soft drinks. So this group of people who do not fall in either of the groups are what we are looking for. They neither like juice nor do they like the soft drinks. So it means the total number of people out of this survey who do not like juice and at the same time do not like the soft drinks are 4. So probability that a person selected from this group that was surveyed will be that person who does not like any of the drinks. Then we find that the probability will be obtained by the number of favorable outcomes, which are 4, divided by the total number of outcomes in that given event. So what is the total number of outcome in this given event? We need to get, this is 10 plus 2 plus 14 plus 4. That gives us the total number of outcome in this given event. So we get, this is 4 out of 30. 4 over 30, if we simplify, we are having 2 over 15. So we have 2 over 15 as the probability of that person selected randomly will be a person who does not like juice and at the same time the person does not like the soft drinks. So we have 2 over 15 as our probability. Part C of the question requires us to get the following. So we have to get the probability that a person selected randomly from this group of individuals likes juice or soft drinks or both of them. So what does it mean? It means that we are getting the probability that the person likes juice, the probability that the person likes soft drinks, and at the same time you have those who like both juice and soft drinks. So total number of people who like juice is 10. Those who like both juice and soft drinks, we have 2. Those who like soft drinks only, we have 14. So we have 10 plus 2, which is 12. 12 plus 14, we are having 26. So we have a total of 26 people who like either juice, soft drinks, or both of them. And we had a total of 30 participants in this given survey. So it means that the probability that the person selected at random will like either juice, soft drink, or both of them will be obtained by the favorable outcomes. In this case, we have 26 over the total number of outcomes, which is 30. So 2 into 26, that is 13. 2 into 30, we have 15. So probability that a person selected at random will like juice or soft drink or both is 13 out of 15. D, part D of that given question asks us to find the probability that So what is the probability that a person selected randomly from this group will like either juice or soft drink, but not both of them? So those who are liking, it is either this person likes juice or the person likes soft drinks. So the number of people who like juice, we have 10. Then those number of people who like soft drinks, we have 14, which gives us a total of 24. That is not 28. So we have 24 as the total number of people who like either juice or soft drinks, but not both of them. So this means probability that a person picked will like either juice or soft drink, but not both of them, we will have 24 out of 30. So 6 into 24, that is 4. 6 into 30, we have 5. So the question now comes in. The question that comes in is this. What is the difference between part C of our question and part D of our question? We are having the question here that this person likes juice or soft drink or both. Then at this point, the other point is this person either likes juice or soft drink, but not both of them. So what does it mean? It means that here our OR is inclusive. So this is an inclusive OR. So inclusive in that it includes the other category of people. That is those who like both juice and soft drinks. But in this case, the other case, we are having an exclusive OR. In this case, what has it done? It is excluding those category of people who are liking both juice and soft drinks. So here, it is including these people who are liking both the drinks. So we have juice and soft drinks. Both who like juice and soft drinks are included in this given equation. But in this, we exclude the group whereby they like both types of drinks, in the juice and the soft drinks. So this one, our OR is exclusive, our OR is inclusive in this case. So a question comes in and we ask ourselves, we've talked about those events that are mutually exclusive, in that when one event occurs, it hinders the occurrence of the other event. For an example could be when we are tossing a coin. When we toss a coin, when the head is tossed, then it means it hinders the possibility of a tail occurring. There is no way you will toss a coin and get the two sides at the same time. When one of the event will occur, it will hinder the occurrence of the other event. So this is a mutually exclusive event, whereby the head has hindered the occurrence of the tail. So that interference or that hindrance is whatever we are referring to as mutually exclusive events. How do we represent mutually exclusive events on a Venn diagram? So if I'm having two events and they are mutually exclusive, then you simply draw the two circles that are representing the two events, but they will not intersect. We've been drawing circles where the events were not mutually exclusive, in that we were intersecting the circles. But when we are having a mutually exclusive event, then our circles will not intersect. So we are talking about the case of tossing a coin. When a head appears, it will hinder the occurrence of a tail. So you simply draw the two circles, but you don't intersect the circles, so that this will simply tell that those are mutually exclusive events. Each one of them occur at its own. So there are some cases where you can have more than two events occurring. So if we have more than two events occurring, it means that we will not only have two circles, but we will have more than two circles. So we have a triple Venn diagram. In this case, we have more than two events occurring. Let us look at a triple Venn diagram using the following question. So we have a group of supermarket shopper who is surveyed on their age, gender, and whether they shop using a trolley or a basket. So the Venn diagram is summarizing everything. We have female, we have age 40 years and above, then we have those who use the trolley. So female, in this case, we are having 22. Out of 22 female in this list, we have 5 who are 40 years and above and are still female. We have 10 in this case who lie in the 3 categories. They are female, they are above 40 years, and they use trolley. Then we have 20 who are female and use trolley. Then we have 15 who are age 40 years plus and they use trolley. Then we have 30 who are 40 years plus, and we have 14 who use trolley. And here we have 4 who fall in neither of these categories. They are not female, they don't use trolley, and they are not 40 years plus. So what does this mean? This means that these are men categories. These are men, but these men are below the age of 40 years. That is why they don't lie in any of these categories. We have those female, we have 40 years plus, we have those who use trolley. But these ones, they don't fall in any of these categories. So it means that these are men, but they are below 40 years. So that is why we are having the 4 on the other side. So the first question is, how many shoppers participated in the survey? So we find out the total number of shoppers who participated in the survey by simply adding the digits we have in this given Venn diagram. So we have 22 plus 5 plus 30 plus 15 plus 14 plus 20 plus 10 and plus 4. So this gives us a total of 120 people who participated in that given survey. Part B. So we need to find the number of people who are aged 40 and over. So we get the number of people who are 40 years and above by simply looking at the Venn diagram carefully. So we are having those who are age 40 in this group, we have 30. But still, in addition to these who are 40 and above years old, in this case, we have 15 people who use trolley and are still 40 years and above. So it means we add 15 to this case. In addition, we have 10 who are female and at the same time they use trolley, but they are also 40 years and above. So it means I add 10 on my digits. And in addition, we have female who are 5 in this case who who are above 40 and above years old. So it means in addition to what I have here, I simply add 5. So when we get 30 plus 15, that is 45. 45 plus 10, 55. 55 plus 5, we are getting 60. So the total number of people in this survey who are 40 years and above is 60. So we get the probability, give the probabilities that a randomly selected participant, part 1, uses a trolley. So we need to find the probability that a person selected is going to use a trolley. So we come to our box, our circle that is indicating that the people who are using trolley. We discover that we have 14 who uses trolley. We have 20 female who uses trolley. We have 15 people who are 40 years and above who uses trolley. We have 10 who are female and at the same time 40 years and above but still uses trolley. So what does it mean? I'm having 14 plus 20 plus 10 plus 15. When we get 14 plus 20, that is 34. 34 plus 10, we are getting 44. 44 plus 15 gives us 50. 44 plus 15 gives us 59. So we get the probability of people who participated in this survey that used trolley will be 59 over the total number of people, which was 120. So probability that a person selected at random from this particular group will use a trolley is 59 out of 120. Part 2, we need to get the probability that a person selected at random from this group is a female. So we are looking for a female from this group of people who are surveyed. So we move to the circle that is indicating female. So we have female. We have this circle that is showing as female. Out of the female, we have 22 female. Then we have 5 female who are aged 40 years and above. We have 10 female who use trolley and are 40 years and above. Then we have 20 female who use trolley. So what does it mean? In total, how many female do we have in this given survey? We are having 22 plus 20 plus 10 plus 5. 22 plus 20 gives us 42. 42 plus 10, that is 52. 52 plus 5 gives us 57 out of 120. If we simplify, 3 into 57, we are having 19. 3 into 120, we have 40. So we get the probability that a person selected from this group will be a female is 19 out of 40. So probability will be 19 out of 40 that a person that is selected at random from this given group is a female is 19 out of 40. Part 3 of the question. Part 3 is we find the probability that the person selected is aged 40 or over. So we get the probability that the person selected is 40 or over. So we move to the circle that is indicating those people who are 40 plus years. So we get that we have 30. Then in addition, we have 15 who use trolley. We have 10 who are female and use trolley. Then we have 5 who are female but don't use the trolley. So we have 30 plus 15, 45, 45 plus 10, 55, 55 plus 5, we get 60. So probability will be 60 over 120, and when we simplify, we are getting a half. So probability that a person selected at random from this group will be aged 40 and above is a half. Part 4. Part 4, we are supposed to get the probability that the person selected is a male and uses trolley. So probability that the person selected is a male and uses trolley. So this means that the circle that is containing female will not be covered. Any digit that has a circle with female here, this circle will not be included. So the circle that has female in it, we are counting it out. So any digit that will appear with this circle, that means 5, 10, and 20, should not appear in our answer because these ones are automatically female. We already know that they are female. Then whatever we are looking for are male. Then another condition is that this male should be using a trolley. So we are looking at where they are using trolley. So we are using trolley. So we find out we have 14 who use trolley. At the same time, we have 15 who are 40 years and above but use trolley. So it means that the total number of people who use trolley is 15 plus 14, which gives us 29. So probability of finding a person who is a male and uses trolley will be 29 out of 120 as the probability of a person selected at random is using a trolley. Next is find the probability that a person selected is a female. This person should be a female and younger than 40. So now we are dealing with this circle for female. So we are looking at a female, but this female should be below 40 years, should be younger than 40. So this means that the circle that has people who are greater than 40, I'm counting it out. So this circle that is showing me the people who are having age of 40 years and above, I'm counting it out. So I'm looking for female. A female that is younger than 40. It should be below 40 years. But we've not been told whether he's using a trolley or not. So in this case, we have 22 female in the survey who are carrying out the shopping. Then we have 20 who are using trolley. So 22 plus 20. 22 plus 20 gives us 42. So probability of getting a female who is younger than 40 from this survey will be 42 out of 120. 42 out of 120, if I simplify, 2 into 42, we are having 21. 2 into 120, that is 60. Then 3 into 21 is 7. 3 into 60, we are getting 20. So the probability that the person selected at random is a female who is younger than 40 is 7 out of 20. So we get the probability that the person selected is younger than 40 and uses a trolley. This one doesn't matter if it is a female or a male, but whatever we are looking for is that the person should be younger than 40. So it means I'm still eliminating these 40 plus years, but it is dealing with any person, be it a male, be it a female, as long as he's using a trolley and younger than 40 years. So we are at the point where we are using a trolley. Then we have 20 plus 14. So 20 plus 14 gives us 34. So probability will be 34 out of 120. If we simplify, we are getting 17 out of 60. So the probability that the person selected at random is younger than 40 and uses a trolley is 17 out of 50. So we discovered that Venn diagrams helps us in indicating or finding out the probabilities of even more than 2 events. So here we are having 3 events. We have a female, we have use of trolley, and we have age 40 years and above. So it means that the Venn diagram has helped me in finding out the probability of the 3 outcomes. At the same time, using a Venn diagram, it is possible to tell if events are mutually exclusive or not. So using this Venn diagram, it is very much important that when the data has been collected, we use the Venn diagram in order to interpret whatever information we have. The Venn diagram will just help us in summarizing whatever information has been collected from the field. Thank you for listening.